Back. So now we are looking at derivative of the arcsine function. Let y equals sine inverse of x. In other words, sine of y is x. So notice y is between negative pi by 2 and pi by 2, and x, which is the domain of sine inverse, is between negative 1 and 1. Now look at this, sine y equals x. Take derivative of both sides with respect to x. Derivative with respect to x of sine y is derivative with respect to x of x. So the right hand side is simply 1. The left hand side looks for chain rule. Derivative of sine is cosine, but the argument here is y, so you need to multiply by dy dx. So mind you, y is sine inverse x. We are looking for derivative of y with respect to x. So we are almost there. So dy dx is 1 by cosine y. Y is a function of x, so I don't want that y there. I want this to be written in terms of x. Recall, sine squared plus cosine squared. No matter what the argument, as long as the argument are the same, sine squared y plus cosine squared y is 1. That is, cosine y is plus minus square root of 1 minus sine squared y. Now notice, my y is between negative pi over 2 to pi over 2. So cosine y in this particular domain is actually non-negative. It is greater equals 0. In other words, I don't need the negative square root. Cosine y is actually positive square root of 1 minus sine squared y. Therefore, derivative of y, which is sine inverse x, is 1 over cosine y. Cosine y in turn is square root 1 minus sine squared. So derivative of sine inverse is 1 over square root 1 minus sine squared y. Remember, sine y is x. So that is 1 by square root of 1 minus x squared. So derivative of sine inverse is 1 by square root 1 minus x squared. This is the formula, and this is valid when x is between negative 1 and 1. I should actually mention here, we don't take equality when we talk about derivative, but I have included this in case we are thinking about one-sided derivatives. So here is your formula. Derivative of sine inverse x is 1 by square root 1 minus x squared. So suppose my function fx is sine inverse of 1 minus x squared. That is, it is a composition of two functions, the arcsine, and this is a polynomial. Find its domain and its derivative. To find the domain, notice the domain of sine inverse is negative 1 to 1. In other words, 1 minus x squared has to be between negative 1 and 1. If I subtract 1 from all the sides, I get negative 2 less equals negative x squared less equals 0. I have subtracted 1. Now, I don't want negative, so multiply throughout by negative 1 and the inequality flips. In other words, 0 is less than x squared less than positive 2. That is, when I take the square root, x is between negative 2, square root 2 and positive square root 2. See, you see, when I take square root, because this is x squared, my x is allowed to be negative, you see. So the domain of sine inverse of 1 minus x squared is the closed interval negative root 2 to positive root 2. Now to find the derivative of my original function fx, I need to use chain rule. Set the argument 1 minus x squared to u. Then du dx is negative 2x. So at this point we can go on. Derivative, that should be d by dx of fx, is d by dx of sine inverse of 1 minus x squared. But that's u. So d by du of sine inverse u times du dx. That's the chain rule. Now derivative of sine inverse is 1 by square root 1 minus argument squared times du dx we just saw was negative 2x. My question was in terms of x, so I need my answer in terms of x. U is 1 minus x squared. So I'll write that here and square it. Instead of u, replace it with the expression. Now when you open it, what happens is negative 1, and that's a negative 2x squared. That becomes, because of that, positive 2x squared. This becomes positive x to the power 4 inside, but with the negative here. So 1 cancels the 1. What I'm left with is x squared common, 2 minus x squared here. And numerator is a negative 2x. So that one of the x's cancels the x, and I'm left with, it should be negative 2, but that negative, I flip this and you have x squared minus. So final answer is 2 by x times x squared minus 2. Okay. Now next lecture, continue. Next topic in this section is derivative of the arc cosine. So we want to define the arc cosine. So let's come to this in our next video. Until then,